lots of items from the online shopping like Amazon, right, Myntra. So you just select the items from the merchant website, right? You place your order, and then you can that means you can payment the cost of the item from your bank account to the merchant's account, right? So you do not have to pay the cash, the physical cash to the merchants, right? So online payment system is popular nowadays. So various kind of online payment system we are familiar with, like credit card payment system, right? So you have the credit card. So whenever you are purchasing some item, you provide your information to the that means the merchants. So merchant will that means take the information of your credit card, and then the information will be used to deduct the amount from your accounts, right? Similarly, the smart card based electronic payment system, right? So there are many debit cards are available nowadays. So almost all we are using this kind of payment services, right? Similarly, the physical check are you people are familiar, right? So similar kind of payment system is also available. That is called the electronic check or e-check system. So like your physical check, right? So you can put a request to your bank that you want to draw a e-check of certain amount, right? So bank will issue an e-check and delivers to you, right? So bank will ask you to the amount and the other information that should be given into the e-check. So bank will generate the e-check and delivers to you. So later, if you want to purchase some of the items, so you will just submit your e-check, right? So the merchant will accept your e-check, and then merchant will process through the payment gateway, right? So that means the online e-check is also one of the online payment system. Similarly, the electronic cash or digital wallet. So now if you, that means if you just use the transportation, your metro rail. So nowadays, the metro rail company, they are actually providing the electronic card, right? So you can deposit your hard cash or physical cash, then you can purchase some of the electronic cash, right? And that should be available to your wallet. If you want to do any kind of transactions, the required amount will be that means deviated from your wallet, and then the same amount will be credited to the merchants or the service provider. So these are the some of the online payment mode nowadays we are using. Now, you see, for this kind of online payment system, so what are the entities involved here? Suppose I am giving the example of the e-commerce website. So there must be some seller who wants to sell the item digitally, right? Buyer, that means the user, want to purchase some of the items from the seller. Issuer or the financial institution, that is the bank, right? Where the seller is actually registered, right? Similarly, the user is also registered to some of the bank, right? Financial institution. Acquirer, that is a payment gateway you are familiar with. Suppose you are purchasing some item, you are doing the online transaction. So the transaction will be provided, that means the processed by the third party, that is the payment gateway, right? So some of that is the acquirer. This is also another financial institution who is a third party, and its role is to process various payment card transactions, right? So seller actually wants to purchase some item using the credit card, maybe debit card, maybe electronic cash, or maybe the digital cash, right? So all these things can be processed by the acquirer. Acquirer process it, and then it will inform to the issuer bank, and the same amount will be deviated from the seller's account, buyer's account, and the same amount will be credited to the buyer's account, right? So what are the protocols or the steps involved in this kind of electronic cash system? So the seller or the buyer, they have to open an account to the registered bank, right? So the bank should be also registered to the acquirer, the third party who will process the transactions. the user will withdraw some eCash. So some eCash procedure, the withdrawal of the eCash procedure is involved. So user will first draw the eCash. The eCash will be payment to the buyer, right? And then the buyer will provide this submitted eCash to the acquirer, right? So acquirer will process it, and the acquirer will find the eCash is correct. So it will inform to the issuer, or that means the financial bank. Then the bank will debited the amount from the seller's buyer's account and then credited to the seller's account. So these are the protocols involved to process the electronic cash. So what is the difficulty here, or what is the problem with this kind of online that means payment system? So here you see the buyer will that means the user will purchase the item, then information will be submitted to the seller, right? Seller will submit this eCash to the acquirer. Acquirer will process the eCash or online transactions. If it is correct or incorrect, and accordingly the acquirer will inform to the issuer or bank, right? Then if everything is fine, then issuer will ask the buyer or the user that the issuer wants to debit some amount that is equal to the value of the items the user purchased, right? And then sometimes it will ask some of the OTP, right? I think the user are that means familiar. If you want to purchase some of the items, so you will log into the bank's website using the ID password. So only the ID password is not sufficient nowadays, right? So bank will use some mechanism that is called the out-of-band authorization. It needs another kind of authentication factors. It will send some OTP to your mobile device, right? Then the correct OTP will be provided by the users, and if it is correct, then the bank will do the transaction. So here you can think about this is a two-factor, one of the two-factor authentication mechanism. Your identity password is required. So here password is a hidden or the secret credential, one factor, right? Similarly, on demand, right? Whenever you are doing the online transactions, so OTP is also needed. That is another authentication factor. So two-factor authentication. So that means the bank needs the out-of-band authorization. So this adds the another layer of security. So it is a time-consuming process. Why? The buyer will draw the first request the bank to issue the eCash. Bank will issue the eCash, and it will deliver the eCash to the buyer, right? So buyer will submit this eCash to the seller, right? Seller will submit this eCash to the acquirer. Acquirer will process all this, and then accordingly it will inform to the bank. Then the bank will debit the or credit the amount, right? So all these things. So there are many middlemen are there. So they will charge some kind of processing fee or transactions fee, right? And it also involves the third party, the middleman, right? So these are the difficulties of this kind of online payment system. And another important the issue is that is called the double spending. So you draw a eCash, that is or e-check, right? So one e-check you have drawn of suppose 25 rupees. You are purchasing two items of 25 rupees. That means with one e-check of amount 25 rupees, you are purchasing two items and total amount is 50, right? So that means you are spending same e-check to purchase two different or more than two different items, right? So that is a double spending. So users are not honest, right? So they are doing some kind of malicious transactions, double spending the same eCash. So it is a responsibility of the acquirer who actually process all these transactions to detect whether the same cash, same eCash or e-check is deposited earlier by the same user or not. So this is quite difficult to detect the double spending. So there are many methods are available for the online eCash system, right? So it is also that means adds another level of difficulty to prevent the double spending of same eCash, right? So these are the various drawbacks of the online, the traditional online payment system. Now we want to get out from all these kind of troubles. So we need some other kind of mechanism. So now the question is that do we have any other kind of mechanism which can eliminate all the third parties, if we eliminate all the middlemen on the third parties, so we can reduce the transaction fee, we can reduce the transaction time, right? We can make the transaction anonymous. I want to purchase an item and the seller wants to sell the item. So the agreement should be in between the seller and the buyer. So even the seller will not know the identity of the buyer, right? So that is called the anonymous transaction. I want to hide my information, right? So if there are third parties, so this kind of anonymous transaction is not possible. Bank will know the buyer is purchasing and accessing in which website, right? So all this information is known to the bank. So that is why we want the anonymous transaction. We want to eliminate the middleman. We want to reduce the time. We want to reduce the transaction fee or the processing fee. So the answer is yes, we have a kind of distributed system or peer-to-peer network system, right? We'll come later. So the audience, are you familiar with the distributed system? Audience?
Yes, sir. Yes, sir. We are familiar with the distributed system.
So can you tell what is distributed system?
Sir, internet is the best example for the distributed system.
Yes. Because here single node will not process the request.
Yes, sir.
Simple
Yes,
answer,
sir.
right? So there are
Yes.
multiple nodes are available. You can distribute your task into different nodes, and the different nodes will process your task, and they will return the answer to you, right? So yes, your example is very good example. That is the internet is the distributed network. Similarly, like Google search engine, right? So millions or trillions of requests is submitting in a moment. So how that can be answered by a single server? That is not possible. So it is actually answered by many servers, right? So Google search engine is also a kind of distributed system. Similarly, our telephone network or cellular network, because a number of base stations are distributed among different locations, right? So your call is not served by a single base station, so it will be served by many base stations. Similarly, if you look into the cryptocurrency, that is the Bitcoin network, it is a P2P or distributed system. Similarly, the other examples are like cluster computing, grid computing. So in distributed system, a number of nodes are interconnected via some network, right? Because we need some kind of connection between the nodes. Those are located in different places, right? So we need some kind of communication network. And all the nodes are capable to send and receive the message, right? But here you see the nodes or the computers, those are connected. Their behavior is categorized like honest, right? So one honest node, that means it will behave or it will respond according to the protocol, right? Maybe some of the nodes can be faulty. It may be due to software failures, or it may be due to some hardware failures, or it may be some other failures. So these nodes are not active and not responding right in some particular moment. So the honest node is fine. Have a faulty node, they will not participate in the network, right? Because it is faulty. But the problem is with that a kind of node that is called the malicious node or Byzantine node. Malicious node means it is active. It can act. If you send some that means request message, it will respond. But you see, it will not as per the protocol. So it is a malicious node. It is doing something and it is telling something. Like, you know, in your friend circle, some of the friends may be there, right? Don't take it other way, right? So whenever you are trying to decide in some critical discussions, right? So he is actually giving some decision, but actually he is doing something different, right? So malicious activity you are saying is doing. So that kind of node is called the malicious node or Byzantine node in the Bitcoin network. So the Byzantine node, this name comes after the problem that is called the Byzantine general problem. What is this problem? So this is a problem in the distributed system. So you see suppose the city is Byzantine. So there are 4 army generals, right? So they want to attack the city. right? So the four army generals must agree on the common decision that whether they will attack or they will retreat from the city or they will step back, right? So if majority of the army generals decide to attack the city, then they will attack, right? Otherwise they will step back. But the problem is that some of the generals are not honest. They are behaving maliciously, and they are called the traitors or the teachers, right? So maybe they are telling that yes, please attack the city, but whenever that means the other generals are attacking the city, but the traitors is not attacking the city. They are just silent, right? So that is why. So this kind of problem is always, this is the inherent problem in the distributed system. Some of the node will behave maliciously. But what we have to do? We have to reach a common decision, right? With the presence of the honest node, with the presence of the faulty nodes, or with the presence of the malicious node or the Byzantine. And that is called the consensus algorithm, right? So this problem is called the Byzantine generals problem. And this problem was solved in 1999 by Miguel Castro and Barbara Liskov. And this algorithm is popularly known as practical Byzantine fault tolerance. This algorithm tells how to reach a common decision in presence of the honest node, faulty nodes, and the Byzantine nodes. So this is one of the important consensus protocol used in the blockchain technology. So now we'll try to devote for the discussion of the blockchain technology. So I think the audience have a clear idea. So why we are actually moving from the traditional online payment system to a cryptocurrency payment system using blockchain, right? So anyone have idea of what is blockchain from the audience? Any idea about the blockchain?
Yes, sir.
So what is blockchain?
Sir, blockchain is a decentralized and distributed system through which two or more users can exchange the data in a secure way. So there is no centralized entity involved for the communication between the users. So it is a kind of peer-to-peer network.
Yeah, so that is also a kind of distributed network, right? It is a peer-to-peer communication.
Yeah, yes.
Okay. So, okay. So let me draw a diagram. So I think my screen is visible to all, right? So suppose there are four participants in the network and they are forming a distributed peer-to-peer network, right? So suppose this is a mesh network. So blockchain means, so here this is a blockchain network. So suppose this node A, this is B, this is C, and this is D. So A has 50 rupees, this is B has 40 rupees, D has suppose 10 rupees, and C has suppose 0 rupees, right? If A wants to purchase some item of suppose 50 rupees, right? So A can purchase a item of 50 rupees, right? And then the same information is all must be that means available to all the other nodes, right? So that means he has 50 rupees and he purchased some items of 50 rupees. Now the remaining balance of A is 0. Now if the next time if A wants to purchase some items, right? So the others node will know that he has no balance in wallet and he cannot purchase any item. If A wants to spend the same amount to purchase another item, so that is called the double spending, right? So all the nodes must be aware. And this kind of technology is called the transparency, right? So that all the information are transparent to the remaining nodes in the network, right? So they know what are the info, that means the transaction performed by A, right? And all the information are available in a ledger, right? So you know the term ledger is used for the banking technology, right? So the suppose one transaction is performed by A, right? And another transaction is performed by B, then the another transaction is performed by suppose C. So all will be just linked together. So this way, the chain of information is available, and all the entire chain, the copy of the entire chain will be available to the all the nodes. So that is why it is a distributed network, right? So this chain will be available to A, D, B, and C. So when A wants to perform some transaction, so the rest of the network will see that A are doing something different, right? Which is not allowed. So that is why the blockchain is a chain of blocks. So all the blocks are not independent. So they are connected, and they will appear as per their creation time, or that is called the in chronological order. And all the information are transparent. So the information in this chain, that is known to everyone. Information in this block, that is also known to everyone. Information in this block, that is known to everyone in the network, right? So that is why the information, that is the entire operation is transparent to all the nodes. And all the nodes are added as per their creation time. And the tempering of one block is computationally invisible. We'll see later. If I want to temper, suppose this block, I am maybe the node A, this is not honest node, this is a Byzantine node. It is a malicious node. It wants to temper the entire chain, right? It wants to temper this block. So there are some hard problem or NP problem. The computer science people can understand what is NP problem, right? So if this block wants to temper by a malicious node A, so A has to solve some NP problem, which is not possible within polynomial time, right? So that is why the involvement of some NP problem ensured that the immutability or the tampering of the chain is not possible. So we'll come later how this immutability will be achieved. You can see the chain of blocks will be created over the times, and they will be linked together, right? So that is why it is a blockchain, chain of blocks. Okay, distributed ledger technology. That means, as I shown, each the same copy of the node, same copy of the chain must be available to all the nodes, right? So that the genuine copy of the chain is available to all the nodes. So that the information about all the blocks should be known to every block, every node. So this is the concept of the distributed ledger technology. So the blockchain is popular due to that the blockchain is decentralized. It is immutable. You cannot change any of the blocks. You can, but it will take huge amount of time, which is exponential time. That is not possible. The informations are transparent to all the nodes. It prevents the double spending. You cannot spend the same e-cash or same e-check twice, right? And the blockchain will provide the security based upon some cryptographic algorithms. We'll see later. So what are the algorithms involved to provide the security in the blockchain technology? So the type of the blockchain, one is the public blockchain. Public blockchain means anyone can join the network. This is a network. So the network is available publicly. So if anyone wants to be interested to join the blockchain network, they can join. Anyone interested to leave the network can leave, right? So that is the public blockchain. So the information about all the nodes, or information about all the nodes are not known to the network administrator, right? If it is a public blockchain. Some of the example of public blockchain is Bitcoin network, Ethereum, Cardano, Dogecoin, right? Private or permission blockchain. So here, not everyone interested to join the network, right? So not everyone wish to join the network can join the network, right? So this is a private, right? Some suppose in your university is maintaining a private blockchain. So only the university employee can join the network, right? If any interested node wants to join, so the node first be authorized by the network administrator, then the network administrator will allow, right? So in this case, that means all the nodes are known and trusted. right? So the example of the private blockchain is Hyperledger, Ethereum Enterprise, RT Corda, Ripple. So they are the example of the private blockchain. Another kind of blockchain that is called the consortium or the hybrid blockchain. This is a combination of the some part is private and the some part is public, right? So the this kind of the application of the consortium blockchain is going fast. Like in the application of the consortium blockchain is Internet of Vehicles, IBM Food Trust, right? Swisscoin. So these are the example of the consortium blockchain. Suppose one that means the important personality is that is traveling from one point to another point. So the information about the personality must be kept secret, and this is not available to the blockchain or maybe available in encrypted form. But when the moving from one point to another point, maybe there are some kind of road accident. So that information must be publicly available, so that the emergency, so that the hospital, that means the healthcare personnel, they can reach to the spot and they can provide the service, right? So that is why who is the important personality due to security reasons that can be hidden, that can be encrypted in the blockchain. But at what location the accident happens, right? So at what time? So this information may be publicly available. So you can understand some of the information is hidden and some of the information are publicly available. So that can be used in the consortium blockchain. So here you see that in the blockchain, as I said, it is a chain of blocks. So chain of blocks. So a block has two parts. One is header, another is payload or the data part. This is the header, and this is the payload part. So now you try to understand the different fields of the header part. So the first field, that is for the block version. You know the version. So initially blockchain is provided, that is blockchain, right? Version suppose 1.0, right? So over the times, maybe there are some bugs or problems, right? So it is evolved or it is modified. Maybe some of the features is added to the new version. Maybe the new version that is available 2.0. So over the times, it is evolved, it will added new features, and it is moving from one version to another version. Previous hash block I'll discuss. So what is the previous hash block? Node, market key root, block. It is a public blockchain or private blockchain or hybrid or consortium blockchain. This is the creation step, right? So who is the owner of the block? Who actually created this block? Right? So the public key of the signer, because some of the information can be encrypted and digitally signed by the owner of the block. So that is why we need the public key and the private key, right? So those who are familiar with the cryptography, so they know what is public key and the private key, right? So private key means, so it is only known to the owner. I am the owner, my private key will be known to me only, right? Known to owner. But it is public key, so it is known to everyone. So, right, so that is why this public key information, it should be available to the blockchain. If I use this public key to encrypt some of the messages, right? And this is the payload field, so it includes a number of transactions. Various type of transactions are available here. You see in the public, so the transactions are available in the plain text form. But if it is a private blockchain, so they are in encrypted form. It will be encrypted by public key of the owner, right? And if it is a consortium, some of the transactions are publicly available and some of the transactions are encrypted. That is why it is a consortium blockchain. So up to now, what I have discussed, the things are clear to the audience. It is clear to the audience.
Yes, sir.
Okay, fine. So now
Yes,
we'll
sir.
discuss a few things about the history of the blockchain, right? So as we have seen that we moved from the online payment system to the peer-to-peer payment system, that is the blockchain technology. In 1981, David Chuang proposed the blind signature scheme. This is one of the cryptographic tools. And later, he has invented online ecosystem based upon the blind signature scheme. So blind signature means you want to digitally sign some documents, but you do not know what is the actual content of the document. I want to draw a e-case, right? What is the amount of the e-case, or what is the that means to whom I want to I want to pay it. So that information is hidden in the ecosystem. Bank will not know, but bank will anonymously sign it. So that is the online ecosystem based upon the blind signature schemes. In 1991, Stuart Haber and the Scott Tornetta, they have first introduced the concept of the ecosystem, which later evolves as a blockchain technology, right? So it introduced the concept of the timestamp in the digital document. Involvement of the timestamp, so you can see if I create a digital document and the timestamp of the current time is involved, later I cannot create the same digital document with the previous time. So that is why it will prevent the tampering, right? So you know, one of the important technology that is called the marklet tree is used in the blockchain technology. So the marklet tree is invented by the Ralph Markley in 1979, and after that, actually this is a patented technology. It is a patent, right? So in 1992 it made publicly available. So then the marklet is used for the blockchain technology, though it is actually designed in 1979. In 2002, Stephen Nost developed general theory that means how a cryptographically secure chain is used, because you know the blockchain is a chain of blocks. So all the blocks are cryptographically secure so that you can provide the immutability. So Stephen Nost first coined the idea of how the blocks can be cryptographically chained with security so that you can provide the immutability. In 2004, Hal Finney introduced the concept of digital e-case, right? So whenever you are just creating the digital e-case, the e-case can be the double spent, right? So Hal Finney gave the idea about how to prevent this double spending problem. In 2008, so this is the history of the blockchain technology. Satoshi Nakamoto, this is an anonymous name. It may be a group of people or maybe a single people introduce the concept of distributed blockchain, that is online ecosystem, right? It is a peer-to-peer network. And Satoshi Nakamoto first published this white paper and released the Bitcoin code in the year of 2009. In this distributed payment system, they use the marklet tree, right? For work as a consensus algorithm because it is a distributed network. So with the presence of the various kind of nodes, so you have to reach to a common decision. That means a block is valid or invalid. We need some kind of consensus algorithm. For work, this is the consensus algorithm that is used in the blockchain network, especially in the Bitcoin. It uses the cryptographic hash to create a hash chain. Cryptographic hash. It will provide the immutability using the cryptographic hash. Here, this is a public network, right? Bitcoin is a public network. Any node can join or leave the network. Now, that means in 2009, so Bitcoin starts working, right? So the 2014, this year is a turning point of the blockchain technology. Why? Because up to 2014, so blockchain technology is only concentrated on the cryptocurrency network. So how actually we are anonymously mine or invent that means the compute the cryptocurrency, right? And then we can use the cryptocurrency anonymously. So only the blockchain technology is limited to the cryptocurrency. But in 2014, so it emerges as a blockchain 2.0, next version of the blockchain. And now 2014 onwards, blockchain technology can be used in many other applications. So all these applications are not purely distributed. There are some central agency that governs the entire network, but it's a kind of distributed network. Like I want to use in the Internet of Vehicles to design the smart city, to design the healthcare application, right? So I do not need the payment system in this kind of application, but I want my network should be transparent. The information should be transparent to all. My network, the information should be immutable. None can forge over the times, right? So this kind of, if you have any kind of application, you want to develop an application where the transparency is a major issue, immutability is a major issue, so you can use the blockchain, right? So nowadays here you see blockchain is not only limited to the cryptocurrency, it can be used for general application like cluster computing, grid computing. There are financial institutions like fintech, in banking technology, right? There are many ways the blockchain is nowadays used. In 2015, the Ethereum frontier network was launched. It enables the developer to write the smart contracts. So you know the smart contracts. So it is a set of codes, right? So in that is Bitcoin or blockchain technology, human will not directly involve to verify the node or to validate the node to addition the node, right? So a set of codes is available. A set of rules or agreement. They are digitally programmed. If the condition meets, the program will automatically execute it, and the node will be validated, and the node will be added to the blockchain, right? So that is called the smart contract. In 2016, a bug in the Ethereum was that is found, which that bug was exploited. The Bitfinex Bitcoin exchange was hacked, and 120 Bitcoins being stolen. So this is a kind of you can see the loss in the history of the blockchain. In 2017, Japanese government recognized Bitcoin is a legal currency, and right in 2018, Bitcoin value continued to drop, right, and then reaching the value to the $3,800 at the end of 2018. 2019, Ethereum network transaction exceed 1 million per day, right? This is a huge amount of transaction, right? So Amazon also announced the general availability of the Amazon managed blockchain service in their cloud computing service AWS. In 2020, the stable coins were demanded as they promised more stability than the traditional cryptocurrencies. Ethereum launched the Beacon chains in preparation for the Ethereum 2.0, right? In 2020, the Ethereum has shifted because initially the Ethereum, when the Ethereum was start working, so it is used the proof of work as a consensus algorithm. It has a lots of drawbacks we'll discuss later. So 2022 onwards, the Ethereum network is start working the another important consensus algorithm that is called the proof of stake. So proof of work is based upon the concept that means if you have the more computational power, right, you have the more chance to become a validator, right, to validate a newly created node. And proof of stake, that means if you have a more wealth or more stake, that means suppose you are joined in a Bitcoin network and you is one of the user, you wants to that means you want to be a validator for the newly created nodes. So you can validate if you have more stake or more wealth, right? Or if you have more computational power, you can become the validator. Proof of stake, that means if you have a more Bitcoin or more wealth, then you can become the validator. Now we'll discuss the blockchain components. Blockchain is a chain of blocks, right? Each block contains a set of transactions. Each block contains a block header and the payload part, right? And each block is linked together. It is not like that they are independent. And a copy of the entire chain must be available to all the nodes, right? Suppose you are a new user, you joined a blockchain network. So when you join the network, so first you will download the entire copy of the chain, right? So that you know what is the current, what is the latest information available to the block. So all the information must be available. The entire chain must be available to you. So now you see the kind of nodes used in the blockchain, full nodes. You know, if you visit the Bitcoin network, you see now the size of the entire chain is 530 gigabytes. So you can imagine what is the amount of space needed if you want to store the entire chain, right? So it is not like that all the nodes are interested to keep the information about the entire chain. A full node, it will keep the information about the entire nodes. If that is the full node has the sufficient amount of storage. Light node, it will store only the partial information, not the entire information about the chain. Mining node or the validator node, so there are suppose 100 nodes in the blockchain, not all the nodes interested to become the validator, right? Maybe out of 100, only 50 nodes are interested to become the validator or the miner. Because you know that to become the validator, so suppose the proof of concept is used, then proof of work is used, then you have the high-end PC where the more computational power, right? Then only you can. Otherwise, otherwise there is no meaning to join the network. Why? Because it needs a lots of computational power. Otherwise, you cannot succeed always, right? So that is why not all the nodes are interested to become the miner or the validator. Some of the nodes can. So these are the type of the nodes available in the blockchain network. The block itself a component in the blockchain. The smart contract, yes, it is needed because set of automated agreement or codes are needed. If the conditions are met, the code will execute it automatically, right? And accordingly, the consensus protocol will be executed. The node will be validated or invalidated, right? We need the consensus algorithm is also an essential component in the blockchain network. Similarly, the cryptographic algorithms are playing a vital role to provide the security in the blockchain network. We'll see the digital signature, encryption algorithm, hash algorithm. They will provide the vital role in the blockchain network for the security purpose they are using. So these are the common fields for the header, right? Like version number, double hash of the previous header of the previous block, marklet root, timestamp, bits field, and non-split. So these are the common fields for the header part. Here just I have taken this example from the Bitcoin network. So you can see the different fields and their type and their size. So this is a typical field, that is a version, hash of the previous block, market root, time, bits, and node. And they are the integer type. And the version is of 4 bytes, previous block 32 bytes, market root is also 32 bytes, time 4 bytes, 4 bytes, 4 bytes, like that. So the header field, the size of the header field of the blockchain or Bitcoin network is 8 bytes. You can sum, you can make the sum, and you can see the size of header. Size of header is 80 bytes. So there are many cryptographic hash functions are available. So one important hash function that is called the SHA-256. It is used in the blockchain technology, right, or Bitcoin network. Right? You know, those are the computations people, they can understand what is the easy problem and what is the hard problem. But you do not want to invert, right? If y is given, and if I ask you to find out the corresponding x, this is the hard problem or NP hard problem, right? So we do not have any polynomial time algorithm that can inverse this hash, right? So this y is called the digest value. For SHA-256, the length of y is 256 bits, whereas the length of input is arbitrary, right? So that is why, suppose this is a binary string and its length is arbitrary, right? Whatever be the length, the digest will be always 160 bits. So you can think about this is a kind of compression function. You have an arbitrary length basis, right? You compress it using the SHA-256 hash function, and you are getting a digest of fixed length 160 bits, or this 160 bit or 32 bytes, right? So the previous hash value, that means in blockchain, so blockchain, suppose this is a block at height, this is height I-1, suppose this is a newly created block. I want to add this block, ith block, right? So its height, the height of the ith block, height of ith block is I minus 1. That means the number of block before this block. There are many blocks, right? This is the ith block. So its height will be I minus 2. The number of blocks just before the I minus 1 block, right? So this is called the height. So I want to create a link or hash. So that means I have to hash, double hash of the header. So suppose this is the header of I minus 1. So I will create the hash value, that is 2 times hash of the header of the previous one. And this value will be this field, right? So hash of the previous block. So it contains the hash of the header of the previous block. So it will create the link, right? So this is this block. Did it make sense to all the participants? What is the previous hash block? Does it make sense to all the participants? Participants? Am I connected to the network? Yes. Am I audible to all? Am I audible?
Yes.
Yes.
Yes, sir,
Yes,
you are
sir, you
audible.
are audible.
Yes, sir, you are audible.
Okay. So now here you see the role of the marklet root. So as I said, suppose a user has performed suppose 10 transactions, T1, T2, suppose T10, and they will be included in a block, right? All the 10 number of transactions. So they will be put it into a block, right? So now you can think about, so what is the role of the marklet tree? So now we think about, suppose you want, suppose this 10 files, you want to suppose T10, and you do not have the sufficient storage, right? So that is why you want to store them in a cloud server. So you submitted all the transaction or all the files to the cloud server. Now you know the cloud server may be honest or maybe dishonest, right? Dishonest means it can change your actual file. So how to integrity of all the files will be preserved. So you can use the hash function, right? So again, all the all the files. So you can create the digest of all the that means the files, and you can keep in your local storage. I assume that all the files is of 100 bytes. So 100 bytes into 10. So this is 10,000 bytes. Suppose you do not have this space, but here you see the output of all the hash digest is 160. So 160 into 10, that means 1600. Suppose this space is available. So you can just keep the digest of all these files to prove the integrity of this. Suppose later you ask the cloud server to provide, suppose the 9th file. So the cloud server will provide these 9 files, right? Right? So when the cloud server provides the file number TA9, so you have to check whether this file is correct file or the modified by the cloud server, right? So you can create the new hash of this received file, and then you check whether what you have stored the previous. If it is correct, then the file is correct. Otherwise, the cloud server is actually tampered this file. So this way you can just you can check the integrity of all the files. But here you see, you have to keep all the digest value, right? All the 10 digest value. But is there any mechanism instead of keeping all the 10 digest value, you want to keep only a single digest? H? Yes, market tree will help you to keep only a single digest, not all the 10 digest. So that will reduce the storage requirement, right? So here, this is the application of the Barclay rule. You can see, suppose you have a 4 files, T0, T1, T2, and T3. How a single digest or Barclay root will be created? First, we create the digest of all the files, right? So it is a binary tree. So now here you see, in this level, these 2 digests will be concatenated and create a new hash. Similarly, in this level, concatenation of these 2 hashes will be performed and then create this new hash. Then in the next level, so it will be concatenated H0 and H1 and we create a new hash H, right? So this hash will be concatenated. Sorry, this hash will be stored by you instead of keeping all the 10 digests, right? So this hash will be kept by the owner or the user. Now, cloud server that is stored all the other digests. Now, when the cloud server wants to, suppose the owner asking to provide the, this is example of 4 transactions T0, T1, T2, and T3. Suppose the owner wants to verify the T3. It receives the T3 from the cloud server and wants to verify whether the T3 is correct one or it is tampered. So in this case, the cloud server will provide the following information, right? It wants to verify, suppose T3, right? To verify the T3, what you need? You receive H and you know the T3, right? So to verify this T3, you need this information, right? This information and this information. Here you see, the cloud server will provide not only T3, along with it will provide this H0, which is the concatenation of this H00, H01, and H10. H10. These 2 information are needed. Why? Because if you receive T3, so you can calculate H3, that is the hash of T3. If you concatenated this H10 and you apply the hash, then it will give this value, right? And you already received this value. So if you concatenate these 2 values, then you get the new root. Suppose this new root H prime is hash of this H10 concatenation of this value, right? Whether this is equal to this H, the root value we have just stored. If it is, then this file is correct. So in this case, not only file is sufficient, the other additional 2 value must be supplied by the cloud server, right? So that you can verify this the digest, right? In this case, so this forms a binary tree. So how many values are needed to verify a single file? So here you see this value is needed, right? 1 and this value 2. So that is equal to the height of the tree, right? So if there are n leaf nodes, so log 2 base n number of values. So in this case, your leaf node, that means the number of files 4. So only 2 values, that is log 2 base 4. That is only 2 values are needed with the digest age so that you can verify, right? So, but if you keep linear order, so you have to need all the n-1 files. You do not using the Barclay tree, so you just keep all the digest value, right? So you need all the remaining n-1 values so that you can verify the Barclay root, right? So the Barclay root will play a vital role. Instead of keeping all the 10 digests, just you are keeping a single digest. So Barclay root is nothing but this is the single value of the payload part, right? So, okay. Now the mining part. So how the block will be mined? So here you see, as I said, number of users are connected in a blockchain network. Not all the nodes becomes the validator. Suppose there are 6 nodes, okay, 8 nodes. Suppose they are the participants in the network, right? So they are not. Some of the nodes become the simple nodes, and some of the nodes become the validator or miner. So suppose the these are the nodes, they have the high computational machine. So they want to be validator or miner. And other nodes are simple nodes. They will provide lots of transactions, right? And when a single user provides lots of transactions, so all the transactions will be broadcasted to the remaining nodes, all the nodes. Now the miners will collect all the transactions and they will keep in a pool, right? That is called mempool, right? When the sufficient number of transactions are available, they will put into a new block, right? New block. So a new block, that means these are the transactions, they will include all the transaction and it will create a header part. And now how this block is correct, whether this block created by one miner, it is correct or incorrect. So we need some kind of algorithm that is called the consensus algorithm. Right? In Bitcoin network, so proof of work is used as a consensus algorithm. That means when a node is created, right? So this node, all the nodes, that means this node is, a newly node is created by suppose this node and it will be broadcasted to the remaining miners, right? And all the miners receive this node and all the miners will compete with each other. That means who will validate this, right? So one mathematical hard problem or called the mathematical puzzle that needs to be solved by all the miners. Suppose this is the miner A, B, C, some mathematical puzzle or hard problem. So if suppose the miner B solve this puzzle first, then B will become the validator or miner or leader of this network who will validate this node is a validator node. That means it will find a solution of a mathematical puzzle, which is a NP problem. You know, the NP problem is not possible to solve in a, that means in a polynomial time algorithm, right? So there are no such algorithm. Only the way is hit and trial. Hit and trial, all the nodes will perform. If suppose we have the highest computing machine, so B will get the chance to solve this problem first. Suppose B solve this problem first, so B will validate this node. Now here you see why the B will validate a node. Why all the nodes participate in the mining process. There is no such reward because if I want to compute something, so I have to that means consume. That means I have to perform some computation. So there must be some electricity is consumed, right? So accordingly, I have to get the reward from the network. Otherwise, I will not participate in the mining process. So reward, that is called the block subsidy plus transaction speed. So when all the normal users perform their transactions, they will give some kind of a fee. They will pay this kind of fee to a miner. So this is called the transaction fee. And now a block subsidy, that means the blockchain network itself provides some kind of Bitcoin as a reward. Initially, if a validator validates or create a node, then 50 Bitcoins are provided as a rewards plus the corresponding transactions fee, right? So in every 4 years of time, this reward is half. In 2009, so the reward is 50 Bitcoins plus transaction fee. In after that means in 2012, this rewards becomes half. That means now 25 Bitcoins plus transaction fee. Now in 2016, so it rewards becomes half of this plus transaction fee like that. So every 4 years of time, this reward is up. Why? Because just to control the inflation of the economy, right? So this is the, and here you see over that is whenever a block is mined, suppose this is a block I-1 and a new block I is mined, so that means the gap between block I, that is the 10 minutes of duration, right? So this is the standard time in a blockchain network or Bitcoin network. A block is mined, the next block will be mined after 10 minutes. right? So that means why this 4 years of time? So over the 4 years, total number of blocks will be created, that is 210, this number of blocks. And it actually, if the duration to create one block to the next block is 10 minutes, so to create this number of block is about 4 years of time, right? So that is why approximately 4 years of time, the reward is halved, right? So this is the reason. That means after creating this number of blocks, so it will take 4 years of time. So the rewards will be halved by the blockchain network. So now here you see the end time. This end time field. This end time field, that means the creation of the block. When this block is actually created, right? When this block is created, this is the end time field. But you know, blockchain is a distributed network, so number of nodes is connected. Note the time of all the nodes will be different, right? You cannot control the time of the different nodes, because in my system now the time is 5:24. Maybe in your system it is 5:23. Maybe in some other system it is 5:20, right? So all the times are not synchronized. So you cannot say the exact time of the creation of this node, right? So that is why there are some mechanism imposed by the blockchain network to correct the creation time or end time field. So it says it has to satisfy to create this end time field. It has to satisfy two conditions. So if this is the nth block, so the owner of this block, it will look the previous n-11 blocks. This is n-1 block, n-2, all the n-11 block. So all the 11 block. So you know, to creation of one block to another block, that is 10 minutes of time. 10 minutes of time. 10 minutes of time. So from this 11 to this n block, the total time will be 10 into 12. That is 120 minutes or 2 hours of time, right? So this time, this n field time will be the median of all the time of all the 11 nodes, previous 11 nodes. Maybe I am for the sake of for this example, suppose this first node, its time is suppose 2, second node is suppose 3, third node is suppose 4, fourth node suppose this is 10, fifth this is 11, suppose 6 this is 7, 8 this is suppose 5, 9 this is 8, 10 this is suppose 12, and 11 this is suppose 15. So can you tell me what is the median of this? Median of all. So you can just arrange them in ascending order, 2, 3, 4, 5. So median, how to find the median? You arrange this value, 2, 3, 4, 5, 8, 10, 11, 12, and 15, and you take their median values. 1, 2, 3, 4, 5, 6, 7, 8, 9. So mid value, I think 8. This is the median value. So n field time will be this 8. So you can see this time is actually the time of this 8th node. This is one condition. That means the median of the previous n11 blocks, right? Or another condition says that it should not exceed the network adjusted time. That means in every 2 hours, every 2 hours of period, every node will adjust their time. That is called the network adjust time. Every 2 hours of time, every node wants to synchronize their time. So they will take the previous 11 nodes and take the median value as a network adjust time. So this n field should not exceed, this n time field should not exceed what is the median time plus 2 hours of time. So these two conditions must be made to create this n time field. Now the miner will satisfy both the conditions, 1 and 2, and accordingly decide this time field, right? So this is the n time field. This is the creation time, right? It is not like that this is the actual creation time, but this way the creation time is decided by the network. And the mining, the n-bit field. So as I said, all the miners will competing to solve the mathematical puzzle. So this is a NP problem. We know this NP problem has no polynomial time algorithm, only heat and trial. Right? So heat and trial. So you select the value one by one, then you compute, and then you try to find out a solution of the mathematical puzzle. Right? Suppose so here the mining difficulty is set, and n field is used to set the mining difficulty. One of the problems is involved, that is called the hash inversion. Hash inversion. So as I said, the hash inversion, y equal to h of x. If y is given, so if I ask you to calculate x, this is a hard problem. You cannot solve it. But this hash inversion problem is used. So we do not, that means the network is not asking what is the actual is. So it will share the difficulty. Suppose it will share, suppose for leading the value of x to be found, the whose leading 4 bits are 0 and the remaining are non-zero. Suppose the value is ABCD. I am just repeating, this is the hexadecimal value. So the miner will suppose select the nodes, a random value. Suppose this is N1, right? So it will just provide the hash of the other fields.
இங்க ஒண்ணும் இல்லைங்க, உங்களுக்கு ஏதாவது வேணும்னா அங்க போய் கேட்டு வரேன் சாப்பிடறதுக்கு. இங்க என்ன இருக்குதுன்னு தெரியல, பார்த்து வரட்டா? குடிச்சிருங்க. நான் டீ ஒரு 5.
Hello everyone. There are some noise. Okay. So that means it will select the nonce one by one, and then it will calculate the hash value, then it will match with this target value. This is called the hash target. Right? So which miner finds a value which is less than or equal to this value, right? That means the less than or equal to this value, then the miner will solve this hash inversion problem. So this n-bit field will play the role of to create the mining difficulty. Because you see, to mine a block, suppose this is the block I-1, and this is the ith block to be created. So this duration should be 10 minutes or approximately 10 minutes. Just to preserve this duration 10 minutes, so the mining difficulty will be readjusted accordingly. If you see at some point the mining of the block is less than 10 minutes, so mining difficulty will be increased. If you see, that means if you find the mining, that means the creation of the block is in some point it is greater than 10 points, so mining difficulty will be decreased. So mining difficulty is not always fixed, or it will always not be increased. Sometimes it will decrease, or sometimes it will be increased, right? So this n-bit field is playing a vital role to adjust this mining difficulty. So due to time, so I'm just keeping all the technical details here, right? So I'll share my slides and you can understand so how this n-bit field is used to decide the mining difficulty. In the payload field, you know, in the blockchain, the node, one is the header part and another is the payload part. So in the payload part, the n number of transactions are included. So the transactions and also the smart contract information is also included in the payload field. Similarly, the size of the payload. So what is the amount of payload is included in a block, that should be there. The encryption and the signature, right? Because you want to authenticate the transaction, so you need the digital signature. You suppose you are working in a private network, private blockchain network, you want to encrypt the transactions. So this encrypted information should be there. Different types of block in the network, you know. So as I said, over the time the blocks are created. When the first block is created by the owner of the Bitcoin network, that is called the Genesis network, the first block. So that is created by the Satoshi Nakamoto. The first block, that is the Genesis block, it contains some arbitrary information. Then the next block, that is that actually includes some transactions, right? This is the first block, or you can say this is the 0th block, right? So then it will create a hash of the previous block, double hash of this. Then the next block is created, right? It will contains the double hash of the previous block, like that. So this way, the over the time the chain is in that means the size of the chain is increased. So this the first block is called the genesis block. So the valid block, when the miner create a new block and miner solves a mathematical puzzle, right? So miner will decide whether this block is valid or not. If the miner finds this block is valid one, so this block is called valid block. Otherwise, it is an invalid block. But sometimes two valid blocks can be created at the same time. So one block is valid and another block is orphan block. Because here you see, suppose n number of miners are competing. Suppose two nodes, node A, that means or minor A and minor B, they at the same time they solve the same mathematical puzzle and they find the same node is actually valid, right? So they want to validate the same block, right? So why I'm taking the same block? Because this block contains the same transaction, n number of transactions. These also contain the same number of transactions, right? But the other transaction, so both the blocks cannot be accepted as a valid one. So suppose the network accept this node accepted by the A is a valid one. So what about the node that is found valid by B? That is called the orphan block. This orphan block is a valid block. But when a number of blocks are valid at the same time, only one block will be accepted and other blocks are treated as a orphan blocks. They are valid, but they will not be included in the blockchain, right? So these valid block will be kept. So when the blockchain network accept the block created by A is a valid one and other valid blocks created by the other nodes like B, C, D, so they will be discarded. These orphan blocks will be discarded, right? So orphan blocks can be created due to the various reasons, right? One of the reasons is the network delay, right? Or both that is miner will solve the same problem at the same time. So that is why this is an inherent issue in the distributed network. You cannot tolerate or we cannot avoid the creation of the orphan block in a distributed network. It will always that there is always a chance to create some orphan blocks, right? So you know the smart contracts set of codes, right? So suppose you are the customer, you are purchasing some items, you are placing the items to the merchant's website information, merchant is verified, right? And all this information is correct. Then the merchants found that all the information are correct. Then it will send the eCash to the acquirer. Acquirer process all this eCash and then send the correct information to the issuer bank. The bank will find the information correct. So that is all this. That means every steps, everything is fine. So this is a set of automated codes will be executed automatically. This is the smart contract, right? And if everything is fine, the transaction is valid found, then the seller will send the item to the customer. So you can think about the smart contract is a set of rules that is the set of digital rules or digital programs or digital codes. They will be automatically executed. So organizers, is there any time to discuss? Organizers, do I have the time to discuss more or I should stop here? Am I audible? Okay, I'll take 5 minutes more, then I'm discussing this concept that is the proof of work.
Sir, you can continue up to 10 minutes only, please.
Okay, thank you. So as I told that the proof of work is a consensus algorithm that is actually used in the Bitcoin network, right? So I discussed few things from the Bitcoin, so you must know the consensus algorithm, that is the proof of work. That is POW. So which miner will serve as a validator? So who will solve the mathematical puzzle? So the concept of proof of work is that means you must have the computational problem, because you have to solve some, the miner must to solve some NP problem. This is a hard problem. So if the miners have the that is more computing power, then he has more chance to solve the mathematical puzzle first and becomes the validator, right? So the concept of proof of work, that means you have to spend lots of computation time, and accordingly there are electricity must be consumed, right? So here you see the concept of proof of consensus algorithm is actually designed by Moni Neor and the Cynthia Dwork in 1993. They have designed this algorithm just to solve the problem of control the spam of the email system. Spam of email. Later, this algorithm is actually used in the Bitcoin network as a consensus algorithm. Actually, the term, the founder, that means the designer or creator of the proof of work, have not used this term proof of work. And the term POW or proof of work first coined by the Marcus Jacobson and Ari Wells in 1999. Right? They have used this term. Later, this term is gets popular in Bitcoin network, and that is done by the Satoshi Nakamoto. So in proof of work, so there are many mathematical hard problems. Famous hard problem that is used in the Bitcoin network, that is the partial hash inversion. Partial hash inversion. As I said, the digest value y, that is the hash of x. So we do not have to compute the exact x. So the difficulty level is decided. That means you have to exact the approximate x, where difficulty level is that suppose the first 4 bits is 0 and remaining are non-zero. Suppose A, B, C, D. So this is a 32 bytes value, right? Or 256 bits value. So this is called the partial hash inversion, because you do not have to input the entire x as that means the approximate x, right? So this is called the partial hash inverse problem. So this is actually used in the consensus algorithm. So here the hash function that is used, that is SHA-256, right? This is actually used to solve in the proof of work algorithm. So when a new node joins the network in Bitcoin networks, for example. So which nodes, suppose there are n number of nodes, they are keeping suppose multiple blockchain copies. Suppose this is a blockchain copies having 116 nodes. Suppose B, it has a node, suppose 145 chain with 145 nodes. This is keeping suppose 160, suppose 170 nodes, right? And it keeps suppose 130 nodes. So blockchain networks tells that a chain with maximum more number of nodes, or that is called the longest chain. So longest chain will be accepted as a valid one. So that means if a new node is that is joined, and if you see there are 4 different chains are available, so you will accept a chain with the maximum number of nodes or the longest chain as a valid one. So this is the concept. A chain of blockchain is valid in the Bitcoin network, which has the maximum number of nodes. And you know the term mining. Mining means enter process. That means a node will create a new node. It will create a new node. Then it will compete with the other miners. It will solve mathematical puzzle, then it will validate the node and it will add this node into the blockchain. Add the node in the chain. So the entire thing is called the mining, right? So mining means creation of the node to the addition of the node in the blockchain. So entire process is called the mining. Who is actually mining? That is called the miner or validator. Now, as I said, to keep the duration, the creation time of between two blocks, suppose bi minus 1 to bi is 10 minutes duration. So mining difficulty will be readjusted. So mining difficulty will be readjusted like that. So the mining difficulty, how the mining difficulty will be, so this is the new mining difficulty. So this will be the old mining difficulty times sorry, I'm writing this is the mining difficulty, new mining difficulty will be the old times 2016 by time 2016, right? So this is the, this means this is the time to create the 2016. That means in every, whenever you are creating, that means in that means it is adjusted periodically. If that means a creation of every 2016 number of nodes, the mining difficulty will be readjusted. So this is the time to mine 201 number of nodes, and this is the time or the 10 minutes, that is the expected time, right? So according to what is the previous difficulty, and accordingly this this way the new mining difficulty will be calculated and it will be set every time. That means sometimes the network finds that the mining difficulty, the creation time is less than 10 minutes, so you have to increase the difficulty. Increase the difficulty. And the network sees that difficulty time, that the creation time is greater than 10, so decrease the mining difficulty, right? So this way, periodically or every 2016 block, the mining difficulty will be readjusted, right? So this is the step how the proof of work executed. That means the miner will collect a number of transactions. They will put the transactions in a block, right? They will broadcast the block into the other miners. Then all the miners will start mining, or that means they start solving the mathematical puzzle. A miner who solves the mathematical puzzle first get the chance to validate the block. So that means it will validate the block. That means it get the solution. Now the solution is correct or not. So that means a miner. Suppose this is a miner. There are three miners, A, B, C. So this is the Y and the corresponding X prime. It is solved by A, and the A is telling that I got the solution first. Whether the solution is correct or not, so it has to be validated by the other miners. So the solution, what the solution get by A, it will be again broadcasted to the other miners. Then other miners will verify whether this solution X prime is correct, and accordingly they will send their vote, right? So B will send their vote. If the majority of the networks or 50%, 51% net, that miners will say that yes, this that means the solution is correct, then A will add this newly created node to the blockchain, right? So this way, the mining process will be executed in a blockchain network, right? This is the concept of the proof of network. So there are advantages and disadvantages of the proof of network. Security, that means over the times the chain is growing, and up to now, as such, no security, that means the breaches is found against the Bitcoin network. So it will provide the security using the cryptographic hash algorithm, encryption and digital algorithm. It provides the decentralized network, distributed network, fairness, because every miner will get the equal chance. Because here you see, A will not get the priority over the other miners, right? So all the miners will compete. They start solving the mathematical puzzle. If any miners find the solution first, then that node gets the chance. So it is not like that the miner will, a particular miner will get the chance always, right? So this is called the fairness. Every miner will get the equal opportunity to solve the mathematical puzzle. Similarly, the disadvantage is that huge energy consumption, because to solve the mathematical puzzle, you have to perform a lots of computation, so that will consume the huge energy, right? So it the environmentalists they are against this proof of work consensus algorithm, because it will consume lots of power and it will generate the heat and it will increase the heat in the environment, right? There are some criticism from the environmentalists. 1% network, right? 1% attack. No, the majority of the network, because the majority of the miners give the positive vote, then only A find add the node to the blockchain, right? If 51% or more nodes are corrupted or they collude, right? They can control the entire network, and you see they can create a fake chain, right, with maximum number of nodes. So that is a huge concern or a threat in the Bitcoin or proof of network, right? 51% attack. And the longest confirmation time, you see, because all the mathematical puzzle, it involves the use time, because their duration is approximately 10 minutes, right? Mining time is approximately 10 minutes. So it is a use. Right? So these are the few advantages and disadvantages of the Bitcoin network that use the proof of work, right? Here I have listed cryptographic puzzles. Not only partial hash inversion is one, right? You can use other cryptographic problem like integer factorization problem, integer square root modulo large prime. The integer factorization problem you are familiar with. N is a product of two large prime numbers P and Q. You know N, you have to find the value of P and Q, because the value of N is suppose 1024 bits. So we do not have any polynomial time algorithm. To solve this problem, no polynomial time algorithm. So you can use this integer factorization problem. Similarly, the square modulo, right? You can, X is congruent to A mod suppose P. P is a prime number, right? This X. So you have to find the value of X, which X is congruent to particular value A, right? So this is called the integer square or quadratic residue problem. This is called quadratic residue problem. So this is also a hard problem. Similarly, the other problem that is in Fiat Samit signature. This is a signature scheme proposed by Fiat and Samit. Other signature scheme, Wong, Schnorr, and Samit. Another puzzle that is called the computational detailement problem. Monthly root based puzzle. Here the various cryptographic puzzles that can be used in place of the partial hash environment. So this is all about my talk, and here I have listed few reading materials. Hence, you can go with all these materials so you can get the more information. And now this is the time for the question answer session. Please know if you have any doubt or any questions.
Dear participant, please ask question. Hafizu sir is with us. Please ask if there is question.
Sir, am I audible?
Yes, you are audible.
Yeah, sir. Sir, I am Dr. Upendra Verma from NMIMS University, Mumbai. So I had participated in one of the FDP, which was conducted by IIIT Kalyani. And so at that time, you were the coordinator, FDP coordinator.
Okay.
Yeah. So at that time, I was doing my PhD. and that FDP was very helpful for me in order to complete my PhD. So,
Thank you.
sir, yes, I was working on elliptic curve cryptography during my PhD.
Okay.
Sir, my question is related to elliptic curve cryptography. There is a new elliptic curve cryptography that is hyper elliptic curve cryptography.
Okay.
So, is there any difference between HECC and ECC?
Yeah, actually, I work generally the non-singular elliptic curve. I never worked in the hyper-elliptic curve. So I can suggest one good book, that is Guide to Elliptic Curve Cryptography. So I can share. It's a very good book, so you can get more information in this book.
Yes, sir. Yes, sir. Sir, please tell me the name of book title.
Yeah, so this is the book, Guide to Elliptic Curve Cryptography. You can see in the screen, and it is freely available in the internet. That is written by Hankerson, Manches, and Gladstone. This is, you can think about this is the Gita of elliptic curve. So you can read this book, so you can get more information. So because whatever cryptographic tool we are using, that is always based upon the cryptographic hard problems, right? Like discrete logarithm problems in the elliptic curve version, computational defilement problem, right? Bilinear defilement problem. That is based upon the non-singular elliptic curve, right? In hyper-elliptic curve, there are some other kind of hardness problem, right? Because whenever you are designing the set of elliptic curve points, not all the elliptic curve points or not all the set will provide the equal level of security, right? So,
yes,
so some of the groups will be easy to solve some of the problems. Maybe some group is that means will not provide the security, to secure the discrete logarithm problems, whereas the others, right? So that way, that means in the hyperelliptic curve cryptography, you can using that you can get the different kind of hardness assumption or hardness problem, and accordingly you can design the different crypto system, right? So this is something different from the non-singular elliptic curve. In non-singular elliptic curve, generally we are using this kind of elliptic curve equation, right? Y square is equal to x cube plus a times x plus b, right? In as per my knowledge, this is not in this from y equal to x cube plus something x square terms is also there, plus maybe linear term is absent and the constant term is there, right? Maybe kind of this, right? So you can give the different kind of hard problems there.
Okay, sir. Okay. Sir, actually, I request you please share the title of the book, okay, in chat box if possible.
Yeah. I'll just share the link. So from the link, you can all of you can download this book. This is a very good book.
Yes, sir. Yes, sir.
Right? I share.
Okay, sir. Thank. Yeah, sir. Link is received.
Dr. Upendra Jadhav, no? Yeah.
Yes, sir.
So can you share your contact details where you are working now?
Of course, sir. Okay, I will share to you.
You can drop an email if you have any query. So my email ID I'm just sharing with the chat box.
Thank you very much, sir. Thank you.
Thank you. Yeah, this is my email ID, or also you can find my email ID from the organizer. So yes, you can drop.
Okay, thank you very much. Thank you.
Thank you. So any other participants?
Any further question, please, dear participant, please ask if there is any question. Okay, thank you, sir. Thank you, sir, so much for giving us time. Okay, your precious time. We highly appreciate your efforts, and you have explained very well blockchain and current technology related technologies. Thank you so much, sir.
I would like to thank the organization for this opportunity and also the participant for listening me. And thank you. And if you have any query, then you can drop an email. Thank you.
So today we start doing this session. Tomorrow we'll start the session again at 11 a.m. Thank you so much. You can leave. Participant, you can leave. Tomorrow again we will see you again at 11 a.m.
Okay, may I leave?
Yes, sir.